All right, what's up, guys? In this video, we're going to pick up with some calculus here, and we're going to be differentiating a tower function. So we're asked to compute the derivative of this tower function. So we're asked to compute the derivative with respect to x for x raised to the cosine of x. So basically, for a tower function, we need to rewrite it in terms of an exponential so that we can differentiate it using the chain rule. So remember that x raised to the cosine of x, I can simply rewrite that as e raised to the cosine of x multiplied by ln of x, or ln of whatever our base here is, which is x, and this is what we'll get. So really what we're differentiating now is we're differentiating with respect to x, e to the cosine of x multiplied by ln of x. That's what we're differentiating now. So the first thing that you need to do with these is you need to rewrite it and then deal with it then. Now we're actually going to be using two rules to get the derivative here. The first one here is going to be the chain rule. Remember, the chain rule is written two different, you can write it two different ways. You can write it dy over dx is equal to dy over du times du over dx. That's one way that it's expressed. Another way that you can think about it is written this way: f prime times g of x multiplied by g prime of x. In other words, you take the derivative of the outside, leave the inside alone, multiply by the derivative of the inside. So those are the two ways that it's written. And then when we actually set up the chain rule, and I'm going to show you all the steps, by the way, so don't worry, you're not going to get confused. We're going to have to apply the product rule. So this is basically a derivative practice video. We always integrating stuff, and integration is certainly hard, but let's play around with some derivatives in this video. I love derivatives. So we're going to use the chain rule. So using the chain rule here, we're going to let y equal our e to the u, and that means that u is everything else. So we'll have cosine times the natural logarithm, or ln of x. We need to use the chain rule here. So the chain rule says that we'll take the derivative of y with respect to, so we'll have it dy over du. Well, that's just the derivative with respect to u for e to the u, which you know it's just e to the u. And then we need the du over dx, which is the derivative with respect to x for cosine of x multiplied by ln of x. Now, in that case, we're multiplying two different functions, so we're going to have to apply the product rule. So let me remind you of that. So the product rule, remember, let's say I have two functions two different functions I'm multiplying, so f of x times g of x. For the product rule basically says that I'll take the derivative of my first function x, multiply it by my g of x function, add that to my f of x function multiplied by the derivative of my second function, which is the g of x, so we call it g prime of x. So this would be the product rule from first semester calculus. And now we need to go ahead and assign what's going to be f, what's going to be g. So in this case, f is going to be cosine and g would be ln of x. So if we apply the product rule, looks like we'll get minus sine of x multiplied by ln of x, and then this would be plus cosine of x multiplied by 1 over x, because the derivative of ln of x is 1 over x, and the derivative of cosine of x is minus sine of x. So that's where all of that information came from. And so therefore, we can say that the derivative with respect to x for cosine of x multiplied by ln of x is just going to end up being minus sine of x multiplied by ln of x. And I'm going to go ahead and just write this as cosine of x all over x. So that would take care of your du over dx, or derivative with respect to s for this. That would be your derivative for that part. Now, what the chain rule says is you have your exponential, your e. The chain rule says just put that back in there. So this would be e to the cosine of x multiplied by ln of x. And then what the chain rule says is that you multiply by the derivative of that. Well, that was minus sine of x times ln of x plus cosine of x all over x. So technically you would be multiplying that by this. So this is what you would be multiplying it by. Now we can go ahead and turn it back in to the function that we initially had it in to actually finish the problem out, because remember that e to the cosine of x multiplied by ln of x is the same thing as what we had up here, which was x raised to the cosine x. So you can actually end up rewriting that, if you want to, you can actually end up rewriting it as x raised to the cosine of x multiplied by all of that mumbo jumbo, which is minus sine of x multiplied by ln of x plus cosine of x all over x, and you would turn it back into that tower function again. And that would actually be your derivative of the tower function, your final answer. So our final answer for this derivative here. And understanding a lot of this math just takes years of practice. And again, I have a degree in physics, so I have a bit of an applied mathematics background, but it's not that bad once you actually practice a little bit. So our derivative is going to be quite long, so I'm going to write the answer up here. So the derivative to this is just going to be x raised to the cosine x multiplied by all of that mumbo jumbo, which is minus sine of x multiplied by ln of x plus cosine of x all over x. And that would be your derivative and your answer. So I was running out of room, and I didn't want to go to another sheet when we see paper. So I just put the answer on the top up there, and that would be your derivative. So a little bit of work was needed on that one, but nothing too bad, hopefully. So hopefully everything made sense, and hopefully I was able to clear up any questions that you may have had about this type of stuff. So let me know if you got any further questions. So I'll see y'all next time.